So I want to provide you with the answer keys to all that work we did yesterday. I'm down to, I had 3, I'm down to 2. I'm going to get that one back, right? Well, I don't know where my third one went. They're slowly disappearing. Okay, so those are the first 3. Does anyone want me to do any of those first 3? The first 3 that you guys were assigned yesterday. Okay, cool. Those are the -3 minus x, 3x plus 2, -3x plus 2. Okay, take a look at this page. Here's your key. I'm going to change colors because that blue sucks. That one should be 4x, 7x, x plus 1, x minus 1, and -x minus 2. Would anyone like me to do any of these 6?
The answers were different.
Well, that's a different page. This is the page before that page. Yeah, that page. Yes. Number 5. Okay, let's look at number 5. So, first step should always be to break up your numerator, writing each term over the denominator. So you're going to get -3x squared over -3x plus 3x over -3x. And now we're just going to divide each corresponding piece in each fraction. So -3 divided by -3 is? Anything divided by itself is 1. So that's going to be 1. What x squared divided by x? We can use our exponent laws for this. Dividing same bases. If there is no exponent written, the exponent is a 1. So dividing these bases, I subtract these exponents. 2 minus 1 is 1, and I don't have to write the 1 as the exponent. So it's just going to be 1x. 3 divided by -3 is? A positive divided by a negative is going to be negative, and 3 divided by 3 is? So this is going to be -1. And x divided by x is going to be x to the 0, which itself is also 1. So you're going to get 1x minus 1 times 1, which is just going to become x minus 1. Does that make sense? Like there's a working here you don't necessarily have to show. Like you could go straight from this stage to this stage. You don't have to put the 1 here. You could go straight from this stage to this stage. You don't necessarily have to put the 1 times 1 here. As you guys get more comfortable with the steps, feel free to skip straight to this piece here, as long as you're showing. Excuse me. Yeah. Sure. I guess if you, yeah. Okay. Gershon, make sense? Okay. Does anyone else want to see any of these? Well, once, twice, thrice, sold. Okay. Now, these ones you had the answers to. They were all at the bottom. There was one mistake in there. I don't think there were any others. I think it was just the one. Comments, questions, concerns on any of these? Raven, what are you doing? What are you? Does it have to happen now? Put your phone away. Okay. Yes, they'll run. Number 4. Okay, let's do it. So the steps are the same. Take each term in the numerator, write it over the denominator. So it's going to become 27w squared over -9 plus 18w over -9 minus 36 over -9. And now we're going to march through each piece. Now there are no w's in the denominator, so the w's are never going to change. So let's just look at all these other pieces. What's 27 over -9? Now you've got your multiplication tables. You have access to a calculator for this chapter. Or you can do it in your head. 27 over -9? -3 w squared. This comes along for the ride because there's nothing reducing it. 18 divided by -9 is negative 2. So this is going to become minus 2, and the W comes along as part of your final answer. And then negative 36 divided by negative 9, positive 4. And you're done. Still drawn. Cool? Makes sense? Sort of? Okay. And then there was more. Some of you got to it. If you didn't get to it, I mean, there was a lot more practice. I am going to provide you the answers to the rest of this practice just so you've got them. So I'm going to write them on the left-hand side here just to give you space to still work through these. This first one would be, now, and it's going back and forth. Some of them are multiplying, some of them are dividing. Here are the answers that you're looking for. 10n plus 6, negative 9a plus 12, 24r minus 24. I'm just going to write them all down this side. And you can find them as you're going. Negative 8x squared minus 8x, 42x squared plus 36x. Negative 20k squared minus 30k. Negative 2v squared. Ruben, good morning, sir. You left your handout on that table at the back. 6x squared plus 15x minus 21. 3a squared plus a plus 2. 5a squared plus 3 plus a. Oops, sorry. Way down the page at this point. Oh, and there's more. 9r squared plus 3r minus 4. Negative 3x squared plus 6x minus 2. And there's a 2a, a negative 3x, a 2a minus 1. Oops, sorry again. And a negative 2n minus 4. And I think last but not least, a 2a squared minus 5a minus 25. And a 6y squared minus 12y plus 6. So that list of answers is everything for the next 2 pages. So I would encourage you to write those down, then at least you know what you're looking for as you march through this stuff. There was more practice. Some of you, I don't know if any of you got, did any of you get to this page, the more practice page? Okay, then I'll leave it for now. If nobody, you did? Okay, then let's give you the answers to it. So, the answers to this page would look like this. You'd have an 8x squared, a negative x squared plus x, a 10x squared minus 15x, a, oh boy, 4x squared plus 2x minus 2. Oh, these are hard to do in my head. Oh boy. I'm going to rewrite this one. 2x. That's going to be 4x squared plus 8x minus 5. a 3x squared. It's going to end in plus 14. That should be a plus 13x in the middle there. It's 13x. That should be that guy there. I have to flip the Dilcron, have you got these written down? Or are you checking them? You good so far? What was the smirk for? Did you get these done? Sorry. Gershon. I did call you Dilcron. Gershon. We good with these ones? Okay. I'm sorry. I did again. There's going to be an x plus 1, a negative 4x plus 2, a 4x squared plus 2, a negative 3x plus 4, a negative 3 or positive 3. Let's get rid of that. Start again. A 3 plus 4x, a x plus 1. That's that page. And there's one more. Actually, only one more. We are not doing math tiles. Don't worry, it says without math tiles. Everything we've done is without math tiles. Don't worry about the math tiles. This one's going to be 3x squared plus 6x minus 12. We're going to get a 4x cubed plus 4x squared plus 20x. We're going to get a 5x squared plus 6x minus 20. And a negative 1 minus 6x squared plus 9x. That should have been the rest of that page. So at this stage, at least you've got the answers to the rest of the booklet. We're going to do one more kind of applications of this stuff lesson today. And then the rest of the time is going to be, the rest of the week is going to be for you guys to review. Tomorrow's Take Your Kid to Work Day. I would encourage you to take part in it. Because the whole, I mean, there was a chunk of you that was going to anyway. And yeah, I mean, otherwise, if you're not taking part in it, it'll be a review day. Okay, questions about any, so I just gave you a whole ton of answers. Does anyone want to see any of these? If you did them and you got questions about them. Okay, if there are no questions, then I'm going to give you the last piece. Okay. That's okay. There's examples of it today. Okay, so doing shapes. Okay, so if you didn't do this in middle school, that's okay. It's not abundantly difficult. But this is one of those ridiculous things that. What's up? Yes.
Yeah, me too.
Seriously? Oh my gosh.
Mine just doesn't work like that.
Okay. Hayden asked first. Pick and pass. No, take the whole stack. Pick what you want and pass them around. Okay, so here we go. This is kind of a convoluted way to talk about some of the concepts that we've been looking at, but we're going to do it. It's still good practice. It's a new way of thinking about some of this stuff. And so here we go. So what this is, there's a page here. I'm going to do one example off of either side, and then I'll give you guys time to play with the rest of them. For this first one, we're going to get rid of the letters. I want you to scribble out the M's. Scribble out these guys. Scribble out the M's. And so we're just going to look at the values there. We've got 2 8s, a 12, and a 3. And let's talk this through. So these kinds of questions are going to ask you to find the area and perimeter. Perimeter is something we've already done. There was a couple questions in some of the work I assigned earlier. There was triangles and there was rectangles, and they said find the perimeter of this, or given the perimeter, find me the missing side lengths. That we've kind of done already. It's these area ones that are a little bit trickier. The only area formula you're going to need for this, and I will give it to you now, is the fact that a rectangle area is equal to the length times the width. That's an L and a W there. Because all these shapes on here are just multiple rectangles stuck together. And all you're going to have to do is make those rectangles. So given a shape like this first one, it's kind of an L or a 7 or whatever, and we've got most of the side lengths. We're told that the distance from here to here is 8, the distance from here to here is 12, the distance from here to here is 3, and the distance from this corner to this corner is 8. We're missing this, and we're missing this. Fortunately, there are convenient ways to reason through what these missing sides have to be. Yes, Rashawn. Why 12 minus 8? So 12 is the distance from here to here. This piece. So what you're saying is that this distance here, from here to here, should also be 12? And that this is the same as that? Yeah, you bet. So if this has to be 12 as well, that means if this is 12 and this is 8, this is going to be 12 minus 8, which is 4. That's cool. Which means this side here also has to be 4, because there's nothing slanted or weird here. That's cool. Likewise, what must be true about this double question mark side? This length from here to here. Yeah, it's going to be 8 minus 3. This whole length here, if I include this dotted line, this whole length here is 8. This length is 3. And so this length here must be 8 minus 3, which is 5. With numbers, it's not quite so bad. It gets a lot more interesting when we're going to do some of this with polynomials. Yeah, I know, Juno. So now to find the area, we have this kind of ridiculous shape here. All we're going to do is we're going to break it up into 2 rectangles, and I've actually already kind of broken it up for you. You can break it up into whatever 2 rectangles you want. I included both of these 2 dotted lines here. You only need to actually include one of them. One of these dotted lines, so if I make this line, I don't care which one you want to, you know what, I'll put it to you guys. Which set of rectangles do you want to do? You could either do this long one and this little guy here, or you could do this long one and this piece here. Either one of these, or, I mean, I've got 2 dotted lines here. We could do 1, 2, 3 pieces. Either way you break it up, you're going to get the same result each time. anyone have an opinion about what they want, how they want to see me do it? No, Gershon is like, nobody has an opinion. Okay. Then because I've drawn these dotted lines, I'm just gonna draw them a little bit firmer, and I'll break it up into 3 shapes. Why not? And we've got side lengths for everything. We know this guy up top here is 4, and this piece here is 5. So the area of this piece the area of that shaded region is just going to be the length times the width. So it's going to be 4 times 5, which is 20. Oh, zoom out a little bit. I've got this shape here. I'll shade it in slightly differently. So then the area of this guy is going to be what? Well, length is 4, width is 3. 4 times 3 is 12. Again, you have your multiplication tables. You have access to a calculator now. And then this last piece here, I'm going to color it in slightly differently, is that guy right there. This guy, this rectangle here, and you got to make sure you're using the right side lengths. The distance from here to here is this guy here 8, and this guy from here to here is 3. So the area of the curly shaded in spot is going to be equal to length, which is 8, times width, which is 3. 8 times 3 is 24. And then to find the area of the total shape, what do I have to do? Add them up. 20, 12, and 24. 0 plus 2 is 2 plus 4 is 6. And then 2, 3, 4, 5. The total area, that's 56. Not so bad. Gets more interesting when we add letters. That was, yeah. We're going to add letters to it. Perimeter, you've already done, but I'll talk about it here. Perimeter, again, always is just, this guy is the sum of the sides. So I'm not going to do the perimeter example on this one. We have all the side lengths, and you guys have done this before. You just add them up. 8, 4, 5, 8, 3, 12. Add up the outside, and you're done. I'm going to show you what one of these looks like. Yeah, let's do one of these on the back side. With some letters. Let's do the top one on the back. So, I want to find the area, and I will model the perimeter for this one. This side is 3m plus 2. I don't know this guy. I don't know this guy. This is 3m. This is 15m plus 10, and this is 5m. Even though we've got letters in here now and polynomial expressions in here now, the procedure doesn't change. We're still going to break this shape up into a couple different rectangles. We're still going to have to subtract to find lengths, to find side lengths. And we're still going to have to multiply these things together to find areas. So for something like this, what do we think? Someone give me a suggestion as to where they would like to begin based on what we just did. If I gave you a question like this, where would you start? Where did I start on the previous question? Sorry, Hayden? Sorry? I started up here. Okay. Gershon, what were you going to suggest? Sorry? Even like, yes, we were going to find the missing. But what was the very first thing I did? Like, take it simple, like baby steps. Go, because that's where so many of you guys struggle. we struggle with what is the first step to start, and we need those baby steps. So what was the very first thing I did on the previous page? Yeah, Gershon. I broke it up into different pieces. So the breaking up place on this shape is where? Where am I going to draw the dotted lines to break this thing up? Gershon. Left what? Like over here? Be as specific as you can. I want to make a box here. So you want me to go to this corner and do what? Go draw a line down. Okay, cool. Let's do that. So now I've got a box here. And I've got a box over here. That's cool. Now, all I'm missing here for this box is this little piece right here. We know this distance is 5m. What's this distance going to be? This dotted line distance. This dotted line distance is this side right here. So this is just going to be 3m. So then to find the missing piece, what am I going to do, Jackson? Jackson, what are you doing? To find this missing piece, what do I have to do? Yeah. Yeah, I'm going to do 5m minus the 3m to get this piece here. So 5m minus 3m is what? 2m. Cool. And now I'll do something similar with this guy down here. I need to find this. If I'm going to find perimeter and area, I need to find this side length here. Well, we know the total distance from here to here is 15m plus 10. And we know the distance from here to here is 3m plus 2. So how am I going to find this piece? Sorry? It's going to be the 15m plus 10 minus this guy here. Maybe it helps to draw in this dotted section here. This is 3m plus 2. So it's this whole length minus this little piece here. So we're going to get 15m plus 10. And now how you write out the subtraction is really important. We're going to put the subtraction sign. And now because we want to subtract away this whole thing, you have to put this whole thing in brackets. 3m plus 2. Close the bracket. Equals. Now, when we were subtracting these things, we distributed that minus sign in. So this thing's going to become 15m plus 10 minus 3m minus 2. And now you're going to group our like terms like we did before. Sorry? No, Raven, what was your question? Okay. You're good? Okay. So now I've got 15m. I've got negative 3m. That's going to give me what's 15m minus 3m? 12m. And then 10 minus 2 is 10 minus 2? 10 minus 2. No. Positive, there you go. It's early on a Tuesday morning. I believe you. So we've got a 12m plus 8 here. Now, I shaded in the previous ones. You don't have to shade. We could just label these shapes with numbers. I'll call these shapes 1, 2, and 3. I drew both lines, so I may as well do 3 shapes here. And I've got all of the side lengths. Now, let's do the area first. What we're going to do is we're going to find the area of each one of these 3 shapes and add them up. So, I want the area for shape 1. Again, these are all rectangles. Rectangles are just length times width. So shape 1 is this guy here. It's going to be 3m plus 2 in brackets, this side times this side. I'll write out all of the expressions. Side or shape 2, we've got them labeled, is going to be 3m plus 2 times 3m. I mean, or you could do 1 and 2 together in one big rectangle. It's up to you. But I've got them drawn, so I'm going to split them up. That's going to be 3m plus 2 times 3m. And then shape number 3 is just this rectangle here. I've got, remember the 15m plus 10 is this whole side length, so we don't want to use this. We want to use this guy here. The 12m plus 8, we got to put it in brackets. And we're going to multiply that by 3m. Now I'm going to zoom in on this. This was shape number 3. We distribute them all. We multiply them all, and we sum them up. So again, to distribute, you multiply this guy onto each of the terms inside the bracket. So this thing's going to be 2m times 3m is 6m almost squared. Thank you, Juno. And then 2m times 2 is, it's going to be positive because they're both positive. 2 times 2 is 4, and the m comes along for the ride. That's done. Next one, 3m plus 2 times 3m. That's going to be, distribute it onto both. Three m times 3m is almost times. 3 times 3 is 9. M times m is m squared. Positive 2 times 3 is plus 6, and that m comes along for the ride. Now I've got a 12m plus 8 times 3m. I'm going to distribute that guy onto both pieces. 12m times 3m is, you betcha, 36m squared. 8 times 3m is, it's going to be positive because they're both positive. $24m. I've got my 3 areas. Now we're just going to add them up. And remember, adding means grouping the like terms, which conveniently we have already. This stack is all my squareds. This stack is all my m's. They're stacked by like terms, just the way I wrote it. So I've got a 4m and a 6m. Added those together is going to give me 10m plus 24m. It's going to be 34m, and it's positive. And then I've got a 6m squared, a 9m squared, and a 36m squared. You add that stack, 6m squared and 9m squared is 15m squared. And again, you can use a calculator for this. You've got your number line. You can use whatever tools you want, or you can do it in your head. Just don't screw it up. 6 and 9 is 15. 15 and 36 is 51, I believe. So I'm going to get 51 m squareds. That is the area of this shape. And then perimeter is just the sum. This side plus that 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 side. Which I could model for you if you would like, or I can leave it for you to try. So I guess what I want you to see here is that the work itself is not beyond any of you. It's just a lot. And so where students get bogged down is what I've experienced anyway is that students typically struggle with how to organize their thoughts, which is why I modeled the labeling here or my shading here. Find a way that works for you to organize your thoughts. Keep things that belong together. I stacked my like terms so I didn't lose anything. What I'm continually trying to do is model ways for you guys to approach problems like this. And that's it. There's 4 more of these and I want you to play with them. Does anyone have any questions about what I've done? This is like it's putting together everything we've done. It's multiplying things, it's adding and subtracting polynomials. There is no division of polynomials on this one, but it's all the adding, subtracting, multiplying. And this is what we're going to do for the remainder of today. You have 40 minutes till the end of the block, which is a lot of time. If you'd like to use the whiteboards, feel free. The whiteboards, redrawing these on a whiteboard is probably a really good, well, certainly not a bad idea. Gives you some more space to work. If you want more paper, I've got a blank paper, or I've got a whole bunch of blank paper over there by the printer. This is what you're doing for the rest of class. Let me know if you got any questions. Shobit's here to answer questions too. On your market set, giver. Yes. Raven, now's a good time for you to go. You can go after Raven.